Assalamualaikum warahmatullahi ta'ala wabarakatuh. And hello. Today we're gonna see how green HVAC is implemented in industry, and before that I will walk you through the Malaysian plan, 9th Malaysian plan, 10th Malaysian plan, and 11th Malaysian plan, to see why is actually energy efficiency come up all of a sudden, and why is renewable energy is stressed to be used, and why do we want to apply in HVAC industry also. Right, so under energy efficiency strategies and the 9th Malaysian plan, the government tried to reduce wastage by enhancing energy efficiency and also increasing energy sufficiency. This to reduce the dependence on petroleum products, and we try to use alternative fuels such as biofuels, biodiesel, and other renewable energy. And this includes this renewable energy is aimed to be used in many different industries, including HVAC. And the aim of energy efficiency under 9th Malaysian plan is to save energy in industrial and also commercial sectors. And energy efficiency features such as efficient lighting and air conditioning are involved in this 9th Malaysian plan. So it is stressed here that air conditioning system should be more energy efficient. And to do that, the government launched several fiscal incentives to stimulate the implementation of renewable energy and also the energy efficiency activities and technologies. And the government also gave the investment tax allowance, import duty, and sales tax exemption for equipment used in energy conservation. There are different incentives that they are given by government for companies which provide EE services. EE means energy efficiency services, and to those companies which adopt energy efficiency initiatives. For example, we have pioneer status. This is exemption from income tax, 25% from 2009 onwards, and 100% of statutory income for 10 years. Alright, how it works you can read by yourself. And for the investment tax allowance, we have also import duty and sales tax exemption. And all this tax exemption and tax allowance and so on is to stimulate the activity of energy efficiency activities and also renewable energy activities for companies. The government also give incentives for renewable energy based power plant, not necessarily power plant, maybe also implementation in residential. For example, we have here solar PV, solar photovoltaic, biogas, biomass, and small hydro, and we also have geothermal. And this one is the feed rates or feed in tariffs rates for solar photovoltaic. This rates, this tariff is for 2017, for year 2017. And now in 2020 we do not have feed anymore. We do have, but with certain certain circumstances. Now we have NEM, net energy metering, but net energy metering can be converted to feed, and that one I'll be explaining to you later in later chapters. Right, for example here, for an installation of solar PV up to and including 4 kilowatt, the feed rates, or the government will be paying you about 74 cents per kilowatt hour. And different installation, different capacity of installation will have different feed rates. Alright, this is the first mosque that uses solar PV, solar photovoltaic system in Kelantan, via this feed scheme, this feed in tariff scheme. Right, so this is the incentives that are paid by the government for solar PV installation, for biomass, for biogas, and for mini hydro installation. These are the rates, the feed in tariff that is paid to the user who install or who propose for renewable energy usage at residential or industry, or in industry. Right, so now let's see the Malaysian 10th plan for year 2011 to 2015. We have 5 strategic pillars of this new energy policy, and one of the pillar is energy efficiency, and this valid for industry, commercial buildings, commercial usage, for residential area, and also for transport area. What we can see here, industrial, commercial, and residential area, that must includes the usage of electrical energy that is used in these areas. And of course, when we talk about energy usage, energy utilization, that includes the energy used by HVAC system in Malaysia, specifically air conditioning system. Alright, so in 10th Malaysian plan, there's environmental management, which is an incipient industry with substantial growth potential in green technology. And the key strategies to nurture the growth of this segment includes creating the environment and demand for green technology industry, to spur business opportunities for professional and service providers by developing and enforcing regulation, especially on energy efficiency in buildings for new developments. Again, energy efficiency in buildings. And to encourage the demand in green technology, there's also the government also promote the investment in renewable energy and provide long-term contracts for renewable energy providers, and of course to create the spillover effects on the related domestic service providers. And another activity to promote the environment and demand to promote the demand for green technology industry is by promoting the culture of conservation and efficiency in energy and water use. And HVAC industry involve both tools. We use energy, and HVAC system also use water for most cases in big installation. Alright, so I just take one of the affirmed framework for Malaysian plan, the 10th Malaysian plan. This is the marketing strategy for international international marketing strategy, so to increase the Malaysia competitiveness. One of it is to increase the labeling of environmentally friendly goods and services, such as we have energy efficiency star rating, we have low carbon footprint products, and green building index. All of this is actually the labeling of environmentally friendly goods and services. Okay, in 10th Malaysian plan, the government also create stronger incentives for investment in renewable energy, and the government also promotes the energy efficiency in terms of productive use of energy and improving solid waste management. So we have lots of solid waste, and it can be converted to fuel for energy resources, to conserve forests, and of course to reduce emission and also improve air quality, which again has to do with HVAC system. Right, in 10 Malaysian plan, there is introduction of feed-in tariff of 1% that will be incorporated into electricity tariffs of consumers to support the development of renewable energy. And this allows the customers to sell their generated renewable energy at a fixed premium price for a specific duration. And if you still remember, FIT is already introduced since in 9th Malaysian plan, but now in 10th Malaysian plan we have a different percentage. And there's also establishment of renewable energy fund from the FIT, and this is to support the development of renewable energy. In terms of the government can give grants for researchers to enhance the technology, the green technology more. Yeah, and all the money comes from this FIT, Renewable Energy Fund, from the FIT. Alright, so if we look at this initiative to drive energy efficiency efforts in 10 Malaysian plan, in industrial sector, there are increase, or it is promoted to increase the use of energy efficient machineries and equipment such as high efficiency motors, pumps, and variable speed drive controls. And when we relate to HVAC industry, for example here, variable speed drive controls, we have inverter that is implemented in air conditioning system. Right, up until now we have seen the position of energy efficiency in 9th and 10th Malaysian plan, and now let's look at Malaysian 11th plan, that is for year 2016 to 2020. And the government aims to increase the adoption of energy efficient and low carbon buildings, transports, products and services. And when we talk about low carbon buildings, that means there are highly energy efficient buildings. And when we talk about highly energy efficient buildings, that means that they have good HVAC system or highly efficient energy systems. And by 2020, the energy efficiency target is at least 20% of government procurement will be green. And as action plans, it is to enhance demand side management, or known as DSM. And the main goal of this DSM, or demand side management, is to encourage consumers to use less energy during peak hours and move to the time of energy use to off-peak hours. And user awareness should also be enhanced on energy labeling and also the availability of standards such as ISO 5001 for buildings and MAPS for appliances. And other measure is to enhance the time of use tariff scheme, or known as ETO. And there's also gradual abolishment of special industrial tariff for energy intensive industries. Other than that, there is adoption of energy efficient vehicles, and the government will work with relevant private agencies to do this, especially for public transport. Okay, there is other measures that will be taken to increase or to promote the energy efficiency. This includes My Hijau Mark program for eco-labeling scheme for green product certification. And before this, in previous Malaysian plan, we already used this My Hijau Mark for green products and services, but now it will be expanded for key product areas such as household products, electronic and electrical appliances. Okay, now we go to energy efficiency building standards. In this measure, new government buildings will be adopted to green features and designs as per Skim Penerapan Hijau Jabatan Kerja Raya Malaysia recommendation, and all the existing government buildings will be gradually retrofitted. And the government will also encourage the industry players to obtain green certification for private buildings such as Green Building Index, and this topic will be covered later. Green Building Index. Okay, now welcome to the new topic. Not new topic, it is new subtopic. These are the example of green technologies that are already implemented in HVAC industry, HVAC field. We have here thermal energy storage, hybrid chiller, desiccant dehumidifier system, and inverter split unit. And all of these devices are actually highly energy efficient to fulfill whatever are planned in 9th, 10th and 11th Malaysian plan. Right, first we're gonna take a look at thermal energy storage. So basically these are the schematic of operating schematic of thermal energy storage. Basically it is a cooling system that uses ice, and the water is freezed in this tank, and what freezes the water is the liquid that is circulated in these coils. For example, we use glycol. There are also other fluids that is used for the purpose, but basically this thermal energy storage will provide the cooling during the day, or back up the compressor, back up the chiller to supply the cool air into the space. And during night it will be charging, which means whenever the load is low, the energy will be used to freeze the water in the tank. Okay, and the cool air, the ice, so it will be blown into the space, so the cool air will goes to the space, and the warm air will go back to the chiller. Right, so here's the operation, how it operates. The ice stores are used in refrigeration, like I said, to cover or increase additional refrigeration demand or during peak load. And the device consists of vapor compression refrigeration process. And thermal energy storage system capture low cost energy from the power grid during the night, which is off peak time, and then use this captured low energy to replace high cost cooling energy during the following day, which is on peak. Alright, and large quantity of cool medium stored in tanks such as cool water or even brine, and it is converted to ice during the off-peak times, and the ice will be used during the on-peak time. Cool thermal energy storage, it is good for a facility that has large cooling load during the daytime, or and little or no cooling load at night, and it can also be used in a district cooling system where multiple buildings are cooled by chilled water loop provided by the central chiller plant, meaning to say that this thermal energy storage is used hybrid with the chiller during the day. And heat thermal storage can also be considered as thermal energy storage system. Alright, during the on-peak discharge cycle, the cool solution from the storage tank is circulated to the building load through a plate and frame heat exchanger to provide cool air capacity. It may back up the chiller, or it may be used without the chiller at all to save the energy. And during the off-peak charge cycle, which meaning to say during night, for example, for a commercial building, the chiller circulates a cool glycol water solution through the thermal storage tanks, and the solution flows through the coil that tubes. No, it's not a coil, it's a tube during this off-peak time, and these tubes are immersed in the water. It will form ice around the tube, and after it is fully charged into a solid block of ice, the chiller will shut off until the next cycle. Alright, let's take a look at second technology in HVAC system. So we have hybrid chiller. And what is hybrid chiller? It's actually a combination of condenser and cooling tower into an all-in-one package hybrid chiller. And it is normally used for a building with large loads at very high efficiency and low cost. It is used in larger commercial, industrial, and process application. Okay, why we use hybrid chiller? Because normally a hybrid chiller is energy efficient, and it consumes between 10 and 30% less energy, with 45 to 50% less water consumption. It is easy and cheaper to be installed. It has low operating costs, and it saves space because we do not need a plant room, and it is easier to maintain compared to normal chiller. And as you can see here, we have cooling tower, and this is this pipe is actually from condenser. So the pipe of the condenser will go straight into the cooling tower, and via evaporation the water or the refrigerant in the refrigerant in the condenser will be cooled via evaporation, so it saves space. Alright, next we have desiccant dehumidifier system. Basically this is a desiccant wheel. So the humid outside air will goes into this desiccant dehumidifier system, and it will pass through the desiccant in this desiccant wheel, and as it passes through the desiccant, the humidity in the air will be absorbed by the desiccant, and there we have dehumidified air. And of course this desiccant, after long use, when it already achieve its absorption limit, so we need to regenerate the desiccant, and the regeneration of this desiccant is done by warming up the desiccant by using heater, and the water will evaporate and it will be channeled to the outside, so the desiccant will be dry again and can be used again for dehumidification of air. And the last example here is an inverter split unit. If you can see these figures, there is difference between a non-inverter split unit with an inverter split unit. You can see here we have less fluctuation, so the set temperature the power, the curve of the power, output power vs time, it is quite flat here. That means there is no spike in the power usage. If compared to a non-inverter split unit, there is spike every time the air conditioner is on and off, because the compressor that is normally used in a non-inverter split unit, after it achieves the set temperature, it will be turned off, and when the set temperature the set temperature, for example 16, then when the temperature rises, it will switch on back, and there is spike in the temperature, in the output power, and after it achieves the set temperature, it will be turned off again. and so the cycle repeats itself. So we have many spikes of output power, and this is the energy wastage. You can see here between the peak of the curve and the bottom of the curve, there is huge difference of output power. That means energy is wasted by switching the compressor on and off just to maintain the set temperature. And if you see in an inverter split unit, the compressor is not turned off at all. It maintains, it is switched on all the time, but the compressor has the variable speed. So whenever the set temperature is already achieved, it just slows down. But when the temperature needs to be reduced again, so it increases the speed of the compressor. So there is no spike in an inverter split unit, and there is where the energy can be saved. So it saves energy by verifying the rotation speed of the compressor to maintain the set temperature. So here we have a little temperature fluctuation, just a little. Alright, so when there is high load, so it is turned on to the maximum power. So we have a high compressor rotation speed, and when there is this medium load, normal condition, then the compressor will vary its speed to the normal condition. And when there is very low load compared to the designed load, then the compressor rotation speed is slow. It will be slowed down. So when not required, the unit operates at low power to save energy. So that's how an inverter split unit works to save energy. So this is just power indicator for 1.5 HP inverter, 1.5 horsepower inverter model. I just take it from somewhere, but what I want to highlight here is just the power is never turned off. It just varies from high to medium or normal, or to low speed, to low compressor rotation speed. So I thank you for listening, and see you in my next video. Thank you.